Hello, my name is Rob Reynolds. Welcome to Business Calculus section 2.4. Today we're going to be looking at the product rule and the quotient rule, two very important rules that you won't be able to be successful in business calculus without. So first and foremost, I'd like to remind you that if you go to Blackboard, you'll be able to print off section 2.4 where I have these examples that I'll be going along on my slides. I would strongly encourage you to print off the PDF file and work out these problems with me. I think we learn by doing, and you can actually work ahead and see if you can follow along with the video and kind of see what you're doing as you work ahead. This is not due, but I do believe you should act like you're in class with me, and this is the lesson for the day. So before you begin your homework assignment, let's go through a couple examples together. Again, the product rule, the quotient rule, and then we're going to look at some real life applications about why do you need to take business calculus for a business major. So again, the product rule is the first thing we're going to look at, and there's several ways to talk about the product rule. So when you have a function times another function, the simplest thing to do is just multiply the two functions together. But oftentimes that's not as easy as you may think, because the first function might be x, and the second function may be cosine x. And we can't multiply x times cosine x. And I don't think we deal a whole lot with cosine, but you might get something like x times the square root of 3x. And that's, you can multiply together, but that's more difficult. Oh, I got one. How about a natural log, which you will deal with? The natural log of x times x cubed. You cannot multiply those together. So we'll have to learn, for examples like this, how to do the product rule. And so the product rule comes in many forms. It's the derivative of the first. Write down the second function. If we highlight the first function in yellow and then the second function in blue, you can see there's two functions, so the g at x. So it's the derivative of the first, write down the second, and then the derivative of the second, write down the first. And I've written that out for you here. The book actually uses a little bit different. I learned it as the derivative of the first, but the book says, well, just write down the first. So again, there's different versions of this. It doesn't matter because 4 times 5 is the same thing as 5 times 4. So the order that you do those in does not make any difference. So the point is you just take you're going to be taking the derivative of the function and writing down the other function. You're going to be taking the derivative of one function and then write down the other. The order that it happens doesn't matter. And there's a lot of different songs that you maybe will help. This one uses U and V. And we'll get more into that as we talk about the chain rule, because f at u becomes really important. The derivative of f at u is f f prime u du, and we haven't talked so much about du yet. But here's another one that actually I will be using. Don't like this video, but it's the only one I could find. So that's probably what I'll be using. I like that rule. It says 1d2 plus 2d1. In other words, you just write down the first, take the derivative of the second, take the derivative of the second, write down the first. So I'll be using 1d2 plus 2d1. I found that most students find that the easiest way to do it. On this, again, you could simplify first by doing the FOIL method. Multiply this thing together. That'd probably be the easiest way, but if the directions say use the product rule, then we should probably use the product rule. So the product rule says 1d2 plus 2d1, unless you do it the way that the book does it, which is a little bit different. But I think students find this way pretty easy. 1 just means write down the first function. Don't do anything to it. Take the derivative of the second function. Well, the derivative of 5 is 0, and the derivative of 4x is 4, plus the second function, which is 5 plus 4x, and then d1, the derivative of the first, is 3 minus 4x. So again, I hope you know how to take the derivative of that, yellow, and get to yellow. Then the rest of this is just multiplying and simplifying and combining like terms. And then over here, we need to FOIL first terms, outer terms, inner terms. So the outer terms is negative 20x. The inner terms is 12x for a negative 8x. And the last terms is negative 16x squared. So combining and putting the answers in descending form, I'll get negative 24x squared plus 4x plus 15. Final answer. Here's the author worked it out. They're kind of doing the same thing. 1d2 plus 2d1. I'm just simplifying the equation for you a little bit. Again, I would multiply this out, but it says use the product rule. So I'll demonstrate the product rule. 1d2 plus 2d1. Now the derivative of 1 over x, which is x to the negative first plus 1, is really negative 1x to the negative second, which I'll write as negative 1 over x squared. You can leave it in exponential form, but I don't like negative exponents. So 1 over x plus 1 plus, if I distribute this, I'll get negative 1 over x plus 1 over x squared. So I think I'm going to go after a common denominator here of x squareds, and by multiplying the top and bottom by here by x. And I'll have to multiply this by x squared over x squared. I'll have to multiply this one by x over x. And this one is just already good, plus 1. So final answer could be x squared plus 1 over x squared, because those x's will cancel. So again, trying to simplify this and put it in the best simplified form is important. You probably don't want to leave your answer in terms of A, B, or even C. So try to simplify by, what does simplify mean? Add, subtract, multiply, and divide. And sure enough, here's how the author worked it out, and they got this. Again, you're welcome to look at these slides that are posted on Blackboard on a nice worked out PDF form. Now this one just says find the derivative, but it didn't say use the product rule, so you don't have to do 1d2 plus 2d1. I'm going to simplify first, and the simplified version would be 2x cubed, much easier than the product rule. Simplify first, plus 6x squared, and then if that's y, then y prime would be 6x squared plus 12x. Much easier to simplify first. Again, I'll just rewrite y, and then I'll find y prime. So if it doesn't say use the product rule, I probably wouldn't. Here's, again, the author solution, which you can find PDF files on Blackboard. I think those were the two answers that we got as well. So I've given you lots of examples of the product rule. Instead of taking the derivative of the first, write down the second, plus the derivative of the second, write down the first. We're going to use 1d2 plus 2d1. Next, we're going to talk about the quotient rule. And the quotient rule has a low function and a high function. And so the quotient rule that I'm going to be using is low d high, which stands for write down the low, take the derivative of the high, minus high, and then the derivative of the low, all over low squared. And then the important thing is then we've got a lot of cleaning up to do. Just like we've done in the product rule, we had to simplify. So then at the end, we'll call it off you go. And off you go is really important because that's all the algebra to simplify quotient rule. So again, there's a song, sure enough, to help remember this. The reason why I use songs is because it's a neat way to try to memorize things. You need to have these memorized. You cannot bring a cheat sheet in for your test. So I'm going to show you the song This, which I will be using. Again, I'm not a big fan of the video, but I like the song. Okay, that was just horrible singing. I know you're laughing at me, but I am gonna gonna try to sing that song once or twice in the video, and then you'll be laughing at me more. Be careful. When I ask for the derivative of a quotient, don't get fooled into thinking that you can just take the derivative of the numerator, write it down, and the derivative of the denominator. That's not true. That's not how you'll get wrong answers 99.9% of the time. So I can't just take the derivative of this and write it over here. I've got to follow the rule, which says low, take the derivative of the high, minus high. Oh, by the way, I would strongly recommend putting parentheses right here, because oftentimes we have to distribute a negative along there. So low, d high, minus, and here's my parentheses, the high, and then d low. Well, the derivative of 2x plus 3 is just 2. And I'll simplify this to be that 2x minus 2, and then be careful when I distribute this negative, I have to do it to every term. So I'm left with 2x plus 3, because when you turn by 1, nothing happens, minus 2x plus 2. And I hope everyone sees where I got that plus 2 from. That's the part that students will mess up on. So I must have done something wrong. Speaking of messing up, oh, let's finish this up. So this is just the numerator. All over low squared. There you go. So it's low d high minus high d low all over low squared. So this is nice that the numerator just turned out to be 5 all over low squared. And then I know what you're going to think. You're going to think, well, let's go ahead and simplify this by maybe distributing and getting what? 5 over 4x squared plus 9. Well, two things about that. First of all, 4x squared plus 9 is wrong. You cannot distribute that exponent through addition. You can only distribute exponents through multiplication. So this is true. This is a big false over here. And then second of all, in calculus, the simplified form is the factored form. So let's just leave that in that factored form. That quantity squared is a perfectly acceptable answer. I know in algebra 1 that's not simplified, but in calculus that is simplified. So the next thing we're going to do is try to find the equation of the line tangent, which means, remember, when you find the derivative, that is the slope of the function. And oftentimes we denote the derivative as f prime of x. So after you find the derivative, then you're going to go f prime, and it tells me plug in a 1. Let x be 1. So let's go find the derivative and let x be 1 into the derivative. Well, I can see this is the quotient. And again, you can't cancel here. That's part of a sum. So don't get into that trap. We can't simplify this. So we'll have to do the quotient rule, which says low d high, the derivative of the high, minus the high. Well, I'll put these brackets. There's just the high function, and then multiply that by the derivative of the low. And the derivative of the low is just negative 3. Well, let's remember all over low squared. And remember, I've done the low d high minus high d low, square the bottom, and off you go is the most important part of the song because, well, I won't accept this as an answer. And off you go means do a lot of algebra. This is the part where I would encourage you to pause the video and see if you can't get the correct answer. In fact, why don't you pause the video and I'm going to write down the answer, or I'm going to give you the answer. Pause the video. All right, the answer is negative 6x squared plus 8x plus 1 over 2 minus 3x quantity squared. Now, if you didn't get that, let's see if we can work that out together. Really, what would be really helpful is if we didn't get that, you go back and find your own mistake. That's more powerful than you just sitting here watching me how to work the problem out. Learning from your own mistakes is really powerful. So if you don't take the time to try to find your own mistakes, during these videos, then you're not going to be able to find your own mistakes during a test. All right, so simplifying this thing, I'm going to have to foil this up here. So I'm not going to show every step, but 8x, the outer is, negative 8 minus 12x squared. I hope I do this right. I'm going to leave this negative right here and distribute. Well, actually, forget it. This negative and this negative makes this a positive. And then I'll just distribute the 3. So I'll triple everything. So I just leave this. Because this negative and this negative cancel. This negative is going to stay 12x plus 9. We'll see if I get the same answer or not. I'm getting nervous here. So the denominator is easy. I'm just going to leave that and not simplify it. The numerator says I'm going to do negative 12x squared and 6x squared for a negative 6x squared. I'm going to combine the x's, 8x's, negative 12x, minus 12x, so the 12x's are gone, I'm just left with 8x. And then the last hopefully will be a 1. Let's find out. I've got a negative 8 and a 9. Sure enough, that gives me a plus 1. Looks like I did okay. But remember, the goal now is to evaluate the function at f prime 1. So every time I see an x, simply plug in 1. This is going to be the slope at that line, or the slope at that point. So again, pause the video, crunch this, and see if you don't get the slope, this to evaluate to 3. Again, hopefully the author has a nice visual, maybe a graph of this function, and then you can see the slope really is 3. There's a nice. So they graphed it, and you can see the slope here is rise 3. Well, 1, 2, 3, run 1, something like that. So that's what you're finding. The slope at this point, if you let x be 1. So it gets a little bit harder. A couple other examples. If you would just take the bull by the horn and do low d high minus high d low, that may be difficult. So they're encouraging you rewrite, or I would be calling that simplify. Simplify first would be a good way to don't do the quotient rule, don't do the product rule. I would try to simplify. And to simplify this thing, I think we can just multiply. This is called a compound fraction, a fraction within a fraction. And to get rid of that, you can just multiply top and bottom by this denominator. So look at this. The new function, this is not the derivative. The new function is just 3x minus 1 over x squared plus 5x. Now you can go find y prime by doing the low d high minus the high, and then the derivative of the low would be the 2x plus 5. Multiply all over low squared, can't forget that. All over low squared. And then you simplify. And when all said and done, again, I would encourage you to pause the video and see if you don't get it. You'll get, hopefully, something close to this. And if not, you can go to the PDF file and they've worked it all out for you right here. One thing I haven't talked to you about is the constant multiple rule, which is a more efficient way to work a problem. It kind of simplifies things, especially when things get complicated later on. A quick rewrite of this would be 1/6 times the quantity x squared plus 3x. We don't normally do that. I kind of like the look of A better, but it's certainly mathematically equivalent at step B. To differentiate this, you could actually just pop out the 1/6 and just worry about taking the derivative of that x squared plus 3x, which of course is what? Well, that would be 1/6 times 2x plus 3. So then the final answer, which is a little bit easier to do, otherwise I would have to do the quotient rule. Low, yeah, don't do that. It's a constant, just pop it out. So again, the rewrite here would be 5/8 times x to the 4th. So again, you could either pop out the 5/8 or you could do 4 times that 5/8 and then decrease the exponent by 1. So it's 5 halves x cubed. So just showing you some tricks how to quickly rewrite This guy, there's several things that you could do with this. One way to do it is you could pop out the -3/7, that's just a constant, and you could bring this x to the numerator. Instead of doing the quotient rule, you might want to consider doing the product rule, although I don't think that would be, whenever it's the product rule with a negative exponent, I think it's just easier just to do the quotient rule. But you could now, since this is a product, do 1d2 plus 2d1. We'll see what the author did with C. There's different ways to do that. That's one approach. And then this one, oh yeah, I would definitely leave this 9/5 x to the -2nd. Bring that, leave the 5 down there, but the x comes up to the numerator. And then it's the -2 times 9 is -18. And then decrease the exponent by 1, and then you'd probably get rid of the negative exponent when all said and done, and write that as the final answer with no negative exponents. So that's C. What did they want you to do? Well, of course, 3x minus 2x squared divided by x. How come I didn't think of that? You could have factored out x from the numerator and then canceled the x in the numerator and the x in the denominator, just leaving it with that 3. That's the fastest way to work it. Sorry, I didn't catch that. The application, I kind of run short on time. Here's an application where you might see this in the business world. And you can go ahead and give you a function basically, and they're saying find the rate of change. Whenever you see rate of change, I want you to think about that as the slope. And how do you find slope? Well, that's the first derivative. So if you're following along and you know that the rate of change means slope, and to find the slope, we take the derivative and evaluate it at that point, you've learned the lesson. So go ahead and find p prime, and then evaluate p prime at 5. And you'll be done with that problem. So here's the worked out solution for that, and there's the answer, approximately. That's the approximate symbol. So if you have any questions on this, feel free to email me, and there's plenty of problems in the book. So you can just open up the book and work out some odd problems and look at the back of the book for some answers. But there's, I didn't talk a whole lot about this, but usually when you end up with radicals, you probably want to do a quick little rewrite and write that as x to the 1/3. So again, just a quick recall. If you have x to the a over b, you can write that as the b root of x to the a term. B is on the bottom, so I remember roots. This is called the b root of x to the a. So changing from exponential to radical is an important concept. Hope this video was helpful. Email me with your questions.